All right, so just a couple days left of class here. You will get your final homework paper from me tonight. Isn't that kind of sad, though? You are, aren't you? And I'm going to miss grading them. All right, so 2 classes left then. So first and foremost, when is your Regents exam? Friday the 19th in the morning. So next Friday morning, a week from today, 8 o'clock in the morning. There are 4 things that you will bring with you to the exam. What are the 4 things that you will bring with you to the exam? Your iPad and charger, pen, pencil, and a highlighter. What time do I want you there? I'm sorry, where? Not in the gym. Earth Science is in the gym. We get the library, which is good. No, that's good. We're going to be air conditioned. That's good. That's very good. I mean, if you want to, I'll ask Mrs. Jordan if she wants to switch. No? All right. So we're in the gym. What time do I want you here? I want you here at 7:50. Why do I want you here at 7:50? First and foremost, you have to hand in what? Your iPad and charger. Now, as you hand in your iPad and charger, we need to go into it and check that you've taken off any passcodes. So make sure you don't have a passcode on there. And we've got to make sure that you're signed out of iCloud. Okay? That's going to take a bit for 30-plus people to check that. Okay? And then second, I want to start reading at 8 o'clock. I want to start reading directions at 8 o'clock. I don't want to be waiting for people straggling in at 8:05 and 8:10, so you're holding everybody else up. When will I start reading directions? 8 o'clock. I will have a bell set on my phone. 8 o'clock, I will start reading directions. Okay? So I want you here at least 10 of, so we can collect your iPads, make sure that all those are taken care of. I didn't say your calculator. Why? We're collecting the calculators on Monday. We're collecting calculators on Monday. You supplied your own batteries for those, so you are more than welcome to keep your batteries that you put in there. If not, I will gladly keep them and add them to the surplus of batteries that we have for the following years. So feel obliged, I guess, to take your batteries out of your calculator if you want to. Okay. What else is also due Monday? Your Castle Learning Test. Your Castle Learning Test is also due Monday. Kind of down to the wire now. Make sure that you've at least signed in before you leave today. Okay. When are we holding reviews? We still have a review Tuesday and Thursday. Will I be in school to remind you that we have reviews Tuesday and Thursday? Or I guess I should say, will you be in school for me to remind you that we have reviews Tuesday and Thursday? No. There is a stipulation on Thursdays, though, folks. You can only come to Thursday's review if you've been to another review previous to that. Why do I say that you can't come to Thursday's review unless you've been to a previous one? It's too late. It's too late. If you've not come to a review yet and you plan on cramming the night before, it's not going to happen. Good luck. You cannot come to Thursday's review unless you've been to a previous review. Okay, whether you've attended online or you've attended here. Thursday night's not going to help you. It's not going to help you. You are going to forget more than you will learn in that hour. Okay? So that is the only stipulation. We will also be providing, Monday I'll give you an exam schedule for the Regents, and I will be offering Tuesday, Wednesday, and Thursday some kind of a block where you guys can come in during the day. I'm assuming it's probably going to be between like 11 and 1 that you'll be able to come in. So if you're in a morning Regents, there would still be time for you to come in afterwards. If you have an afternoon Regents, you'd still be able to come in beforehand. But I want it to be consistent all 3 days. I don't want you to have to try to remember, well, Tuesday it's here, but then Wednesday it's here, and then Thursday it's here. So it's going to be consistent, and it's probably going to be like 11 to 1. Will I be putting on a dog and pony show for you on those days? No. If you want to come in Tuesday, Wednesday, and Thursday, then what you'll want to do is you will either have questions ready for me, or you will want to come in and just sit down and take a practice Regents and be able to ask questions as we go. Okay? I will not be putting on a class for you. I've got pre-calc finals that I'm going to have to grade and get their overall grades taken care of. I've got Syracuse finals that I've got to get graded, get shipped back to them, enter their grades. and other exams that I will have to be going to help proctor and score. So I will be extremely busy. I will not be putting on a class for you. If you want to come in and work on a Regents, you are more than welcome, and you can ask questions as you go. Or if you have questions ready for me, that's great. We'll get those answered, but I will not be putting on a class or a review. Okay? Questions? Okay, so when are we collecting calculators? Monday. When are we collecting iPads? Friday at the Regents exam. When you will be here when? 7:50. Okay, you'll be here at 7:50. Questions? All right, homework then. So we've been solving first and second degree trig equations, and we're going to continue on with that today as well, but we're going to throw a twist at you today. First degree trig equations, simple. You just use your inverse operations to get the trig function by itself. You then find a reference angle and apply it to the quadrants where it's either positive or negative. Second degree trig equations, no big deal. We're either going to solve them with what or what? Bless you. Factoring or quadratic formula. Okay, so we'll solve it down, and now we'll have two first degree equations because sine theta could equal this or sine theta could equal this. We again find the reference angles and apply them, just building upon what we did the other day. And we'll continue with that as well today. Now, why did I give you all of 15 through 19? Multiple choice, you should be doing them how? Straightforward in the calculator. So what did you get for 15? Choice number 2, 180 degrees is correct. So why wasn't it 4 then? The 60 and 300 didn't work. You've got to be aware of that though, folks. You saw 0 didn't work, so then you automatically crossed off 1 and 3. But then you went to 180. 180 did work, so is it automatically 2? No, because 180 is also over here. You've got to come over and make sure that the 60 and 300 don't work. It's choice number 2 for 15. What did you get for 16? Choice 3, 60 degrees is the smallest measure, 60 degrees. Number 17, which one was not a solution in 17? Choice 3 again, pi is not a solution. All the others are. 18, what is the solution in 18? Choice 1, 0 radian is correct for number 18. Choice 1. 19, which one is the solution? Choice 4, 240 degrees. 2, 3, 3, 1, 4. 2, 3, 3, 1, 4. Number 21, how were we supposed to do 21? Factoring. And what method did you kind of need to employ to help you along with that? The X method was very helpful in that one. As you solve that one down, you get theta to be 90 degrees. 90 degrees. And then you get a reference angle of 14 degrees. You had to apply into quadrant 3 and 4. So 194 and 346. 90, 194, and 346 for 21. 33, how are you supposed to do 33? Quadratic formula, right? So you set up the quadratic formula. You got the negative b plus and minus the square root over 2a. Now, one of those didn't work. Why did one of them not work? It was greater than 1, right? So that automatically crossed out. And I believe it was the plus one, right? The plus one that didn't work, so it was the minus one that did. And you ended up with a reference angle of 6 degrees. So 186 and 354. 186 and 354 for 33. 35. The option was yours, but it was obvious that you needed to do what? Quadratic formula, right? Both of the cosine values worked, so we ended up with 4 answers. 2842 and 331.18. 2842, 331.18, and then the other set was 9922 and 260.38. 9922, 260.38, 2842, and 331.18. Do we need repeats on any of those last 3? 21 again was 90, 194, and 346. Repeats? Okay, any of the multiple choice questions first. You ran them through your calculator, but you still didn't get an answer, or you still got a wrong one. Any of the multiple choice ones? Good with those? Okay, very good. The other 3? 21? Had to solve 21 how? Factoring. Now, on the Regents exam, will you have the option of whatever to do? Yeah, the Algebra 2 trig regents, I have never seen them say you have to do it this way. Common Core, yes, they say solve it with this method, solve it with this method. But Algebra 2 trig, the option is always up to you, which it always should be. If you're comfortable with one method, you shouldn't have to do it in a different method. Is it already in standard form for us? Absolutely is. But I want the X method to help me out here. What automatically goes left and right? Sine theta. Even though it's 4 sine theta, we're automatically just putting a sine theta. Tell me about my signs, please. Yeah, they're different, aren't they? So 1 plus, 1 minus, and they both need to get divided by the A value of 4. What is the value that just drops to the top? Either right 3 or negative 3. It doesn't make a difference. And what do we do to bring to the bottom? Product of A and C. 4 times 1 is 4. So we have factors of 1 and 4 and 2 and 2. I need the pair that's going to do what? Subtract to give us a 3. And which pair is that? All right, I want negative 3. Is that 1 minus 4 or 4 minus 1? That's 1 minus 4. Okay. Can I reduce this at all, folks? No. Now, can I leave it like that? I absolutely can. I can leave it sine plus 1/4. I absolutely can. But what do we normally do with that bottom? We bring it up top. Well, I'm going to leave it just like this. Sine theta plus 1/4 equals 0. And sine theta minus 1 equals 0. This one's the easier one over here. So if sine theta minus 1 equals 0, then sine theta equals 1. Okay? And we don't need our calculator. We know the angle whose sine is 1. What is that? Not 45, no. 90 degrees. So over here, theta equals 90. That is the only place where sine is equal to 1. Over here, we want sine theta to be equal to negative 1/4. Is that one of our special values? No. 1/2, 0, 1, radical 2 over 2, and radical 3 over 2. Okay, so we need to go into our calculator, and we need to find a reference angle. Okay. How are we going to find that reference angle, folks? Inverse sine, but I need to make sure I'm in what? Yeah, we want to be in degree mode, right? Degree. So, second sine what? What's that? 1/4. Why not negative 1/4? We never do negative with inverse sine. We're finding a what? Again, we're finding a reference angle, which is where? First quadrant, where everything is positive, right? Okay, and they wanted this, I believe, to nearest degree, right? So to the nearest degree, what did we get for a reference angle here? What is it? 14 degrees to the nearest, so 14 degrees. Okay. But where are we going to put this angle, though? What quadrants? Why 3 and 4? Because that's where sine is negative. So how do I put an angle into quadrant 3? 180 plus the reference. So 180 plus the reference angle gives me 194 degrees. Oops. And then how do I put an angle into quadrant 4? 360 minus the reference, which gives me 346. What do I need to do with all 3 of my answers? Check. Can I do the equal check on 90? Yes, because we didn't do what? Can I do the equal check on these 2? No. How do I check those? Side to side, right? I check the left-hand side, see what I get. I type in the right-hand side. They need to be very, 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 very similar to each other. Why aren't they going to be exact? We round it. Okay. All right with that one? Very good. Okay. You do the other 2? 45 again was 2842, and 331.18. And then 99.22 and 260.38. Yep. Okay, so what's our standard form for 45? 7 cosine squared theta minus 5 cosine theta minus 1 equals 0. And as we look at this, 7 times 1 is 7. Are there any factors of 7 that are going to subtract and give me 5? No, there's not. I can't factor this one. We've got to use what? Okay, so DJ, tell me what you got then for what cosine theta is going to be equal to. What did you get for your discriminant? You can go ahead and tell me the full value you got. You can skip to that. 53, and that is correct. 5 plus and minus radical 53 over 14. That's good at that point. Okay, so that means that cosine theta is going to be equal to the 5 plus 1, but cosine theta is also going to be equal to the 5 minus 1, right? So let's take these individually. What is 5 plus the square root of 53 divided by 14? Can we have that for cosine? We absolutely can. We absolutely can. So 0.877 ... Okay. So let's find a reference angle. How do we find the reference angle? Inverse cosine of that value. And here they wanted, what was it? Nearest minute. Nearest minute. So second cos, second answer, and then degrees, minutes, and seconds on that. So to the nearest minute, we're 28 degrees and 42 minutes. 28 degrees, 42 minutes is my reference angle. Now, DJ, though, where does this need to be applied to? Where is cosine positive? 1 and 4. Okay, so the first quadrant angle is the what? The reference angle of 28 degrees, 42 minutes. But how do I put that into quadrant 4? 360 minus. So 360 minus that value and back to degrees, minutes, and seconds. 331, 18. 331, 18. Have you figured out what you did? Okay. And then over here, we're going to go 5 minus root 53. We get that right there. We divide that by 14. Can cosine be equal to that? Yes. So we inverse the cosine, but can I just hit second answer? No. There's two things, one of two things I can do. I want this value to be positive, so I could do what to it? I could take the absolute value of it, or easier, I just negate it. Negating a negative is going to make it positive. Okay. So there's my reference angle. This one needs to be applied to what two quadrants, though? 2 and 3, where cosine is negative, and that's then where you get your 99.22 and the 260.38. All right there? Okay. Today's date is the 12th, so make sure you got your name, date. Go ahead and send those up and over to me, please. As you guys are sending those ones out, I'll get today's back out to you. There are tissues up here if you need them. Seeing that this is the last one I'll give you, I know it's kind of sad. See, Carolyn needs them. And the notes that you need are trig equations with identities, or trig equations and identities, something like that. Trig equations with identities. Trig equations with identities. Okay. We are going to continue on solving trig equations. Some are going to be first degree, some are going to be second degree, but they're not going to be as straightforward is what we've had the last 2 days. Okay? We're going to have to do something else first. Okay? So let me show you an example of something like what we're going to see. 2 cosine squared theta equals sine theta plus 1. What's different with this than what we've seen the last 2 days? First and foremost, tell me, is this a first or a second? Why is it a second? Because of the cosine squared, right? This is a second degree trig equation, but I can't set this equal to 0 and start with the quadratic formula. What's the issue we have? This involves 2 different trig functions, doesn't it? This involves 2 different trig functions. Well, what we're going to have to do is make some kind of a substitution with those identities that we talked about at the beginning of the week, mainly Pythagorean identities. Remember me saying that those are going to be the most important ones for you? We're going to have to make a Pythagorean identity switch here, or substitution, that is going to get these 2 trig functions to be the same. Well, is there anything I can substitute in for sine theta? No, sine theta is sine theta. But is there a switch that I can make for cosine squared theta? There absolutely is. Okay. If we were to refer back to our Pythagorean identities, we would see that cosine squared theta, anybody remember what is cosine squared theta equal to? 1 minus sine squared theta. And how do we make substitutions? So we're going to replace this cosine squared with 1 minus sine squared theta. Set it equal to sine theta plus 1. Is that issue now been alleviated? Issue solved. Distribute 2 minus 2 sine squared theta equals sine theta plus 1. Where am I going to move everything to? The right-hand side, right? So that negative 2 is going to become a positive 2 sine squared theta. That sine theta is already over on the right, so plus a sine theta. How does that 2 come across? We've got to subtract it. So 1 minus the 2 is going to be? Negative 1. And now are we at the exact same point we were at yesterday? Yep, how would we now solve this? Factoring, yeah, this one would be a factoring one. We could solve this with factoring. Or quadratic formula. Now that's as far as you're going to go tonight. That's as far as you're going to go tonight. I don't want you solving them. I just want you making the substitution and getting it to the point where you then would be able to solve it. Okay? I am hoping through the last 2 nights you're all right with solving that equation. Hoping. Okay? But that's not what my focus is today. The focus today is making an identity substitution to getting it to the point where we can solve it. Okay? So we're going to come across 2 issues today, folks. First and foremost is the issue of needing. In this life you have needs and wants. What are needs? Can't live without them, can you? Well, when we're solving trig equations, we have some needs. We need to have my angles be the same. I can't solve cosine 2 theta equals sine theta. Why? Two theta and 1 theta, they're different angles. I'm taking the cosine of one angle and then the sine of some other angle. It would be like solving an algebraic equation that had an x and a y. Can you solve a single equation that has 2 variables? No, if you've got 2 variables, you need multiple equations. Can't do that. We need to have the same angles. Well, what are we going to do here then? There's nothing I can do with sine theta. I can't change that at all. But is there an identity for cosine of 2 theta? Where do you look to for that one? You look to your reference sheet. And your reference sheet has 3 things for cosine 2 theta. One that has a cosine and a sine. One that has strictly sine. One's going to have strictly cosine. What would we want in this particular case? The one that has strictly sine, which would be 1 minus 2 sine squared theta equals sine theta. Has that need now been met? Do we now have the same angle? Sine theta and sine theta. We now have a quadratic which we would set equal to what? That is, a need. That's the first thing you've got to look for when you have a trig equation on your regions. Are all of my angles the same? If they are, progress. If not, you've got to make a substitution that's going to get them to be the same. Okay? There's also some wants. We want to have the same trig functions, like that one we just did. We want to have the same trig functions. We can live without wants, can't we? Okay, there will be a way, if we can't get them to be the same trig function, there will be a little trick that we can do, and that'll be the third example that I show you today. But what are we going to do here? We're going to substitute for sine squared theta. With that same Pythagorean identity, we know that sine squared theta is equal to what? 1 minus cosine squared theta. So I can make a substitution here and say 2 times of 1 minus cosine squared theta, or in this case x, equals cosine x plus 1. Has that want now been met? Yes, that want has also been met. Okay. What would I do to continue here? I would distribute the 2 and set it equal to 0. Okay, and then I'd have the quadratic that I could solve. Okay, so what are we going to use to make substitutions? Well, we are going to use our identities to make substitutions. And there's going to be 3 main types of identities that we use to make substitutions. We're going to be using our reciprocal relationships, we're going to be using our double angles, and we're going to be using our Pythagorean identities. Okay? We know that secant theta is equal to what? 1 over cosine theta. So if we see a secant theta, we can replace it with a 1 over cosine theta. And then how do I undo division by cosine theta? I could multiply everything by cosine theta and then get rid of that fraction. What am I going to replace a cosecant to? 1 over sine theta. And then again, if I don't like that fraction, then I can multiply everything through by sine theta. You're going to see a problem on that like this tonight. I think it's going to be one of your last ones where you're going to have like a 1 over something. Well, then multiply everything by that trig function to get rid of that fraction, and you'll end up with then a first or a second degree equation. What is cotangent equal to? Very good. Cosine theta over sine theta. Unless you had an equation that looked like this. Tangent theta plus cotangent theta equals, I don't care, whatever. What would you change your cotangent to here then? Here, you would change it to a 1 over tangent theta, and then you'd multiply everything by what? Tangent theta. So tangent times tangent would be a tangent squared. What would happen when you multiply this by tangent? You would just get the 1, and it would turn into a quadratic again. Okay? So you normally change cotangent to cosine over sine, unless in the equation somewhere else you've got a tangent. Then you can use your 1 over tangent. And you can use 1 over tangent. Okay? Double angles. You just need to tell me where you can find them and where you would look to on the Regents exam. I didn't make you memorize them. I'm not going to make you memorize them here. I will tell you what they are, but you've got to tell me where you find them. Reference sheet. Sine of the double angle is 2 sine theta, cosine theta. And folks, as you're doing your homework tonight, you need to have this page of your notes right there by you, because you need to refer back to these to make your substitutions. Tangent 2 theta, rarely going to see tangent 2 theta, but if you do, it's 2 tangent theta over 1 plus tangent squared theta. Cosine is a big one. You quite often make substitutions of this. It's either cosine squared theta minus sine squared theta. Are you going to use that one very often, though? No, why not? There's 2 trig functions. You're going to use these 2. 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. and then your Pythagorean identities. We had 9. Did you have to know all 9? No. You had to know the Pythagorean identity, which states what? Cosine squared theta plus sine squared theta. It's one of the first things I strongly recommend for you to do when you sit down to take this readings exam. When I say you may begin, write that on the reference sheet. So we've seen these two already then. Sine squared is 1 minus cosine squared. Cosine squared is 1 minus sine squared. Tangent squared is secant squared minus 1. Cosecant squared is cotangent squared plus 1. Secant squared is tangent squared plus 1. And cotangent squared is cosecant squared minus 1. These are going to be big ones. And how do you spot Pythagoreans? Squares. The double and the Pythagoreans are the big ones for solving equations, making a substitution switch and solving it in. Those are the two big ones. Okay? You want this sheet of notes out next to you as you're doing your assignment. You want to quickly be able to refer back to these to see what substitutions you're going to make. Okay? Everybody have them? All right. So any questions on what we did there? Okay? We saw a cosine squared and a sine. Well, we said, well, we can substitute for cosine squared with 1 minus sine squared. And again, that right there is as far as I want you to go. I don't want you solving the equations. You got to practice with that the other 2 nights. Okay? If you want to, absolutely go ahead and do that. But this is what I'm concerned with tonight. Can you make the substitution and then get it in standard form to where you would be able to solve it? Okay. Here is my necessity. Cosine is dealing with what angle? 2 theta. But sine is dealing with what? Theta. I don't have the same angle, do I? Well, is there anything I can do with sine theta? No, but is there something I can do with cosine 2 theta? There absolutely is, right? I can make a substitution for cosine 2 theta. Where do I look? I look to my reference sheet, and I'm looking at which identities? The double angle identities. And cosine is now kind of up in the air. It's got 3 things. Which one do I want to replace it with? The sine one. Why? Because I have another sign. Okay, so I always make substitutions with parentheses. What are we replacing cosine 2 theta with? 1 minus 2. 1 minus 2 sine squared theta. Minus 2 sine theta plus 2 equals 0, right? Why are the parentheses there? Well, the parentheses are there because we made a substitution, but do I ultimately need them? There's nothing to distribute to them, so let's get rid of them and set this equal to 0. The negative 2 sine squared is going to become a positive 2 sine squared theta. The negative 2 sine theta is going to become plus 2 sine theta. And when I add together the 1 and the 2, I get 3, but that positive 3 is going to go over as a minus 3. And now are we at the point where we can solve that? Yup. Factor or quadratic formula. Okay. So we've used a Pythagorean identity to make a substitution. We've used a double angle identity to make a substitution. Is this the necessity or is this the want? This is the necessity. Okay. So tell me where I would look to make a substitution. The reference sheet, which identities? The double angles. What did we say the sine of 2 theta was? 2 sine theta, cosine theta. equals cosine. Why did I not use parentheses this time? It was by itself over there, right? It was by itself. Okay. Has the necessity been met? The necessity has been met. All my angles are now theta. Can the want be met? The want cannot be met here, folks. I cannot change a sine into a cosine. I can't change a cosine into a sine. The want cannot be met here. Can we still solve it, though? Absolutely, we can still solve it. So what's that trick around not getting the want? Okay. What do we normally set equations always equal to start off with? Okay, how would we do that? I'm going to subtract a cosine off, right? Now, can I subtract a cosine from this term, though? No, why not? They're not like terms, are they? They're not like terms. So I'm going to have a 2 sine theta cosine theta minus a cosine theta equaling, okay. I can't turn one into the other. But can I separate them from each other? How many terms do I have here? 2 terms, right? Just 2 terms. 1 term minus a second term. I've got 2 terms. What do those 2 terms share? So can I factor out a GCF? What would I factor out? I would factor out a cosine theta. And what would that leave me with? 2 sine theta minus 1 equals. So folks, I couldn't change one to the other, but was I able to factor one away from the other? Yes. What are my 2 linear equations now going to be? What am I going to get out of this? Cosine theta equals 0 and 2 sine theta minus 1 equals 0. Okay? So that's why this one is not a necessity. This is just a want. Ultimately, yeah, we would like to have the same trig functions. But if not, are we potentially going to be able to factor them away from each other? Yes, we will potentially be able to factor them away from each other if we can't get them to be the same. Okay? And again, I don't want you solving tonight. I just want you getting to the point where you can solve them. You make the substitution and you simplify it down. Maria? When you do something like that, when you multiply or divide an equation by a factor, when you multiply an equation by a factor, you risk gaining extra roots. We call those extraneous roots, extra roots. When you divide things, you're potentially running into losing a root. So if at all possible, we don't want to multiply or divide by a factor of a variable because we might gain roots or we might lose roots. Okay? And in this case, we would lose one if we divided by cosine theta. We would lose all the answers that this one's going to give me because they would then be gone. Okay? So you do not want to try to multiply or divide an equation by your variable because you run the risk of either gaining or losing roots. Now, gaining roots is no big deal. We just check to see that they don't work. But when we lose roots, that hurts us. Okay? Olivia, what was your question? Yeah, there's 2 places where cosine theta is going to be equal to 0, and there's 2 places where sine theta is going to be 1/2. Yes. Yep, absolutely. Okay. Again, folks, you've got the homework there. It's every other even. And again, do I want you solving them? No, just getting them to the point where we did in the notes. 38 and 39 are 2 multiple choice questions. Do them how? Okay. Have a great weekend, folks. We'll see you Monday. Don't forget your test, folks. Don't forget the CASA learning test.